Alright, what's going on, everybody? As you can see, I had to change the scenery because, my roommate is inside and I think he's going to bed. It's like literally 1:30 in the morning right now and he's got at 8 o'clock. So we're going to respect the privacy and we're just going to chill out in this beautiful, lonely study room. But to the left and right of me, there's people in this room. But, bro, we're trying to get this bread, right? If I'm too loud, they can come in, bro. Never be scared of that, bro. If someone's being too loud, always, hey, you're being way too loud in here. Get out. But no, bro. No one's doing it so far. We're good. All right, so let's get into it. So we're doing the musculoskeletal system. And so, first up, the musculoskeletal system is gonna provide a support upright posture. Look at the curvature of my back right here. You see this? It's because my musculoskeletal system, right? All right, and it's gonna give us a wide range of motion. Look, I wouldn't be able to do this without my musculoskeletal system. Look at me getting sturdy. Look at me getting sturdy, boy. Look at me getting sturdy. Look, I wouldn't be able to do that if it wasn't for my muscular system skeleton. And it's gonna protect our internal organs. If you punch me in my chest, ooh, my heart is good because I have my musculoskeletal system to support me. And it's gonna support our weight. Now, I'm a pretty heavy dude. I eat like pizza and hamburgers, but that's not gonna stop me or my musculoskeletal system from living, bro. Let that sink in, bro. All right, now we have 3 types of skeletal systems. We got hydrostatic, exoskeleton, and endoskeleton. Now these vary. At first, I thought these were for people, but it goes from people to like reptiles, amphibians, reptiles, and like snails, insects, and stuff. And so, what a hydrostatic skeleton system is gonna do, is gonna have a big word called column and hydrostatic pressure and a soft body. These 3 are the characteristics of a hydrostatic skeletal system. Remember, the column, hydrostatic pressure, and a soft body. Really remember the soft body for the hydrostatic skeleton system. All right, we're doing great so far. You're doing great, bro. All right, so a fluid-filled support and compartment in hydrostatic skeletal systems. This is what's going to be known as the coleum. Remember, it's going to be fluid-filled support. Think of like a slug. Ooh, I hate those things. A slug? That's nasty. Ugh. All right, but on top of a slug, think of like earthworms, anemones, invertebrates, or an octopus. Or octopi, if you want to count multiple. And so next up, we have exoskeleton. There's going to be hard acellular encasements. Acellular, no cells. Acellular encasement, defense, movements made of chitin. Molting allows for growth. These are characteristics of an exoskeleton. And a strong polysaccharide encasement in an exoskeleton is known as chitin. Let that sink in, bro. Chitin is a strong polysaccharide. It's made of these little different chemistry molecules. I'm not in chemistry yet. And it's gonna encase it. Yes, I had to repeat it, obviously, because I really didn't get it. When I repeat stuff, it's because I don't get it. It's for my teaching and for my getting my point across. But let me know if I'm being too obvious with it. And so, when an exoskeletal tibia flexes, hey, what's a tibia? Tibia, Google it. And the extensor is gonna relax and the flexor contracts. So you don't have to picture like a bug. Take my arm, look, this right here, my bicep is known as a flexor. And this right here, my tricep, it's known as an extensor. Wait, am I saying that right? So if I flex, look at my bicep. It's slowly getting bigger. It slowly gets bigger. And look, when I extend my arm, my tricep, you can't really see it. I'm trying to see it. All right, whatever. But notice how my bicep is not getting big when I extend my arm. Instead, it's my tricep. My tricep gets longer. It relaxes. Wait. Bro, just like, watch somebody else's video, but come back to my video, okay? Because I didn't do that good of explaining it. But moving on. But when an exoskeleton tibia extends, when it extends, the extensor contracts and the flexor relaxes. I said it right. So my bicep is relaxed right now, but my tricep is engaged. But look, I bring it in, shoop, my flexor is engaged. Bring it out, my tricep is engaged. Yes, bro, doing great. And some examples of exoskeleton organisms is gonna be an arthropod, insects, and crustacean. Yes, Mr. Krabs is an exoskeleton organism. Bro, that's crazy. No, okay, never mind, never again, bro. Why did I do that, bro? All right, so the most effective skeletal system is an endoskeleton. Let that sink in. An endoskeleton. Hey, what are people? We're endoskeleton organisms. Let that sink in, bro. People are endoskeleton organisms. All right. And so we have our skull, our middle ear, a bone known as the hyoid bone, our vertebral column, and rib cage. These are all members of a group known as our axioskeleton. The axioskeleton is one line going straight down your body. It goes straight down your body. Simple. All right, and one of the bones that supports our face and protects the brain, it's our skull. There is hardly nothing in my brain. I just have a skull. All right, but what's gonna transmit sound from ear to oval window, and it's known as our smallest bones. These are gonna be known as, big words here, auditory oscillators. Auditory oscillators, the smallest bones in our body, and they transmit sound from eardrum to our oval window. Now, I don't know what an oval window is. Google it for the life of me. And next up, this group is gonna encase our spinal column, our cervical, our thoracic lumbar, our sacrum, and our coccyx, and our coccyx, and our coccyx. I don't know how to say coccyx. I think I said it right. But this group is gonna be known as our vertebral column. And this is gonna get our spinal cord. I'm gonna repeat it, but act it out. Our cervix, that's somewhere down here. And our thoracic lumbar, our sacrum, that's somewhere where my pelvis is. And yeah. And so we have, what's gonna protect our vital organs is our thoracic cage. Everything above my Texas shirt is my thoracic cage. My heart is right here. My lungs are right here. My pancreas, my thymus, everything is somewhere over here. It's all protected by my thoracic cage. Let that sink in, bro. Yours is protected by that too. All right. And so we have our pectoral girdle right here. Our upper limbs. Hey, it's our arms. Our pelvic girdle. Hey, that's down here. Wait, can I see my pelvis? Hey, that's right here. And our lower limbs. Hey, look, it's my arm. My legs. These are what's gonna be known as our appendicular skeleton. All right? So all of our legs, our pelvis, our upper limbs, anything that's outside of this, outside of our straight line, is gonna be known as our appendicular skeleton. All right. And our pelvic girdle, that's gonna be our thigh, our leg, shins, calves, and our feet. I got my dogs out. I don't want y'all to see my feet. But yes, bro. Easy peasy. We're halfway through. A little over halfway. And so our pectoral limbs, they're gonna be our arm, our forearm, our arm, and our hand. Let that sink in. These are our pectoral limbs. These are your pecs. Ladies and men, these are your pecs. This is your arm. This is your forearm. This is your hand. Oh my God, bro. Whoa, I'm learning so much. And then there's one main difference between a female male pelvis and a female pelvis. The female pelvis is wider. it's gonna be wider. If I was a female, my pelvis will be busting right now. I'd have curves the size of Uranus. And then it's gonna be lighter. I can literally do anything with this pelvis. And it's gonna be shallower. Now, I really don't know what shallower means, but yeah, I don't know what that means in context with the female pelvis. But we have the basic unit of a bone. It's known as an osteone. Osteone. The basic unit of a bone. An osteone. What's the basic unit of a cell? A cell. What's the basic unit of a bone? An osteone. Bro, it's so cool right now. I'm devouring all this knowledge. And so the osteone, well, no, let's enlarge our area, right? And so the round layer of a bone, what you see when you chop off your hand, that's gonna be known as the lamella. All right, easy. The lamella, it's a round layer of bones. Think about it, bro. You see a ribeye, it's a lamella. You're saying that. Well, a steak. Oh, crap. You know what I mean, bro. You know what I mean, bro. All right, and so we're gonna have blood and nerves. These are gonna be known. Wait, there's people outside. I'm distracted by them. I'm so sorry. All right, so there's our Haversian and our central canal. These are gonna be blood and nerves. This quiz is kind of confused me. I don't know what the context of this is, but that's all right. That's okay. It's okay. And so the chambers in a compact bone containing osteocytes, these are going to be known as lacunae. Lacunae? That sounds Japanese. Kota koragune. Lacunae. It's chambers in a compact bone containing osteocytes. Bro, my brain is galaxy brain evolved, bro. Your brain is too. Wow. And so the small canals in a compact bone, they're known as Canali. Culi. That sounds a little bit African, right? The Canali Culi. Welcome to the Canali Culi. These are the smallest in your compact bone. Don't think of your middle ear. Don't think of the auditory oscular, the small bones. It's something entirely separate. Okay? And so next, the bone forming cell. What's gonna make our bones in my flesh? What's gonna make your bones is known as an osteoblast. An osteoblast. Remember the Big Bang Theory? It's a theory. It's not proven. So, boom, a whole universe explodes. An osteoblast, boom, a new bone cell is made. An osteone is made. So that's how I think of an osteoblast. It's a bone-forming cell. And so an osteocyte, it's gonna mature. I tried doing a Mario level, but it didn't work. Okay. It's gonna mature. It's gonna mature the bone cell. It's a component of the lacunae. What's a lacunae? It's a chamber in a compact bone containing osteocytes. All right, bro. And so an osteocyte is gonna mature the bone cell. Okay, bro. We know that part. Let's move on. So the cell that breaks down bone is gonna be an osteoclast. Think of like a clap when you think of an osteoclast. Clap. Osteoblast, boom. A cell is made. Osteoclast, clap. Easy, bro. Easy peasy. It's gonna break down the bone. It's gonna break it down, bro. So next, a really big and long word. The intramembranous ossification. This is a fibrous tissue that develops into the skull, mandible, and clavicle bones. Let me repeat it. A fibrous tissue, the mesenchymal, develop into skull, mandible, and clavicle bones. This is known as the intramembranous ossification. Easy, bro. Now, what's the context of this, bro? This makes your face, your skull, your mandible, your clavicle bones. That's what this intramembranous ossification is. And we have our endocrondinal ossification. It's a cartilage that forms a bone, that forms into bone. Think of like your kneecap, right? I take my kneecap, I have endocrondinal ossification and cartilage forming in my bone, bro. That's pretty cool, isn't it? It is, bro. It is. And so from muscle to bone, that's going to be what's known as a tendon. A tendon is going to connect from muscle to bone. Right here, my elbow tendon, I have muscle. Look at this big meaty muscle. And bone. I have a tendon connecting those two. A tendon is the bridge. It has a tendency to bridge the gap, bro. To bridge the gap between a muscle and a bone. Easy peasy. And a ligament, on the other hand, is going to attach from bone to bone. I can't think of any examples of a ligament right now, but look up at Google ligament examples. And we have thin filaments known as actin. Hey, what you actin for? Oh, sorry, I'm a thin filament. I'm an actin. Bro, I don't know what this means, bro. The context is kind of lack. But on the opposite of that, there's a thick filament. It's known as myosin. Hey, actin, how's it going? Oh, I'm thin. Sorry. Wait, I'm myosin. I'm thick. I'm thick filament. Yeah, I don't know how to put this in a context, bro. I'm sorry, y'all. But myosin is a thick filament, and actin is a thin filament. And what's connected by the fibrous tissue is going to be known as a fibrous joint. This is going to be connected by fibrous tissue, aka your skull. Example, your skull. Fibrous joints. It has plenty of fibrous tissue in it. Plenty of fibrous joints. Plenty. Yes, bro. What's connected by cartilage is cartilaginous joints. So your knee is a great example of having cartilaginous joints. It has ligaments, it has tendons that help connect it, bro, in terms of cartilage. So cartilage joints, that's what your spinal cord is also an example of. I think I said that wrong about the tendons and ligaments on your knee, so I'm wrong on that one. But your knee is a cartilaginous joint. Sorry, I had to prove myself, so Larry Green would hate on me in the comments. But the space between your bone, your knee, and your elbow, that would be known as synovial joints, okay? That's the empty space. Easy peasy. Synovial joints. Hey, that's pretty good. That's pretty good. And the types of joints in order of least to most movement, count with me. Fibrous joints, that's the least. And cartilaginous joints, that's the middle. The most is our synovial joints. All right? Which is the synovial joints again? That's our elbows. That's our knee. Plenty of movement, bro. I couldn't kick out my leg. I got a little scared I was on the kick table again. But we have what's known as a myocyte. This is a muscle cell, our fiber. Muscle cell, myocytes. It's just another word for muscle cell, myocytes. Now a big word, sacrolemma. It's a plasma membrane of a muscle fiber. A sacrolemma. Big word. I think of alligators because I played Ark Survival Evolved. It's a pretty cool video game. And sacro stands for alligator. And the plasma membrane of a muscle fiber. So an alligator has been liquefied. He's been glued up. He's been blendified into a plasma membrane liquid. That's kind of nasty. An alligator smoothie? Goop, goop, goop. Hey, I kind of take a bite of that one. Yes, bro. And next we have sacroplasm. It's going to be the cytoplasm of a muscle fiber. Sacroplasm. Alligator plasm. This alligator's been liquefied. Sacro means alligator. Why has it been liquefied into a plasm? It's just to build up the muscle fiber for the cytoplasm. Easy peasy, bro. All right, last section. One more section. Let's get into it, bro. So we have contractible fibers within muscle cells. That's another word. Another word for that definition would be myofibril, which is, let me repeat, the contractile fibers within muscle cells. I can contract, my biceps contract. There's some myofibril going on around. There's some myofibril activity going on in there. I get a notification from Instagram. Go away, please. All right. Let's get into it. In a sarcomere, it's the smallest unit of muscle. What's the smallest unit of muscle? You said sarcomere? I don't know if you said it, but I'm going to pretend you said it. Yes, the sarcomere is the smallest unit of a muscle. Now, take that word, sacro and mere. Think of mere as the smallest. You can do the bare minimum. Okay? And it's just little, bro. It's just little. Sacromere, little itty bitty. All right. And we have a sliding filament model. It's the sacromeres contract because of the thin actin filaments that slide over the thick myosin filaments and shorten myofibrils. What did I just say? So the smallest unit of muscle, the sacromeres, because of the thin actin filaments, tiny and the thins, they're gonna go inside of each other like you're knitting something. That needle's gonna go into the fabric and it's gonna slide. And it's gonna slide over to the thick myosin and it's gonna shorten the myofibrils. Like this. Shoop. 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 Google what a sliding filament model is. That's it. You've done it. You've passed. Congratulations. Please Google, rewatch the video. I need you to like, comment, and subscribe. And yeah, have a good one. All right, bye. Bye.